Chapter 3, 3-4 review. First thing we need to do is directions say use the change of base formula to evaluate. So how do I do this? How do we calculate? ln of 0.8 divided by the natural log of 9, or log of 0.8 divided by the log of 9. Yes? Now, type that in your calculator. What do you have? Negative 0. Thank you. Okay, next, number 4. Use the properties of logarithms to simplify the logarithmic expression. How is 5 e to the 6th attached? In multiplication, in log world, what is that? Addition. So it's the natural log of 5 plus the natural log of e to the 6th. What happens? Natural log of e's cancel out, and I have the natural log of 5 plus 6. So I'm going to write this as 6 plus the natural log of 5. I write it like that so that you guys don't mistakenly decide to take 5 plus 6 and add them together. Do we understand that? Number 6, please make the change on there. It's supposed to be negative log of base 10 and 1 over 100. I typed it up last night, so I was late.
I just made it both log 10 of 100 with negative first. Wouldn't that work?
Put the negative up front. Okay, now, what do you do here? 1 over 100 is what? 100 is the negative 1. And then what do I have to do here? That negative 1 becomes an exponent, so where's it going to go? Out on the front. So I'm going to have negative 1 times the negative times log base 10 of 100. And what happens to your negative and your negative? To give you log base 10 over 100. Is that what it was up here that I needed it to equal? Yes. So now that I know that they're both equal, I don't have to do anything else. All I want to do is verify that the left-hand side equals the right-hand side. Once I get them to be the same, I'm done. We understand that? Same concept. Number 9. Number 9 says expand each of the following. So I need to expand this thing. Okay, so I need to expand this thing. What's the first thing you notice? Division. What is that in log world? Subtraction. So I have log base b of the square root of x, y to the 4th, minus log base b of z squared. The next thing you notice. Multiplication. X, the square root of x times y to the 4th. So in log world, multiplication is addition. So I have log base b of the square root of x plus log base b of y to the 4th minus log base b of z squared. Now what do you notice that's ugly? The exponents, but what's ugly about the exponents? I have something that's ugly there that doesn't match everything else. What doesn't belong? The square root is what is ugly, and it's misplaced there. So I need to write that as an exponent to make that x to the 1/2 plus log base b of y to the 4th minus log base b of z squared. Now what do you want to do? Bring all of the exponents out in front of the log. So that's going to give me 1/2 log base b of x plus 4 log base b of y minus 2 log base b of z. That is 100% expanded. Do we understand that? Number 13. Number 13's directions say condense. Condense. So if I'm condensing, you will not have enough room in that space provided there. I did not give you enough room. I apologize. You're probably going to give me another sheet of paper out. Did not give you enough room. I guarantee it. Okay. So if I look at this, what do I do first? No. When you expand, the first thing you do is multiplication and division, right? When you condense, the first thing you do is the last thing you do in expansion. What's the last thing you do in expansion? The exponents. What's the first thing I do with condensing? Put the exponents back on. So I'm going to work within my brackets. So 1/3 hangs out. The natural log of y plus the natural log of y plus 4, that 2 becomes an exponent, minus the natural log of y minus 1. Now I'm not going to put that 1/3 on until when? At the end. I need to simplify that bracket on the inside first. So now that I put the exponent back on, what's the next thing I need to put back on? Let's go. It's multiplication. Why is it multiplication? Because it's addition. So I'm going to have 1/3 bracket, natural log of y times y plus 4 squared. Close your bracket, minus the natural log of y minus 1. Married in by multiplication because they're attached by addition. Now, can I do anything else in the brackets? No. So what does that 1/3 become? An exponent, which is actually the cube root. So that's going to be the natural log of the cube root of this whole chunk here, minus the natural log of y minus 1. Now, how are those two natural logs attached? Subtraction. What does that mean in logarithm? Division. So what I have going on here is the natural log of the cube root of this ugly junk all over this junk. And notice I only have one natural log there. I don't have two, I have one. Do we understand the condensation of that? Condensing. That's kind of funny. Try to use the method.
That word.
To use it in that form?
Yeah.
Oh no. I mean, that's what we're doing. Doesn't sound right. That's not what I'm thinking of.
Sounds like it's water.
I know. How funny. Okay, 16. Directions say without using a calculator to evaluate. So if I'm working on number 16, what should you do first? What's your gut telling you?
I would expand it.
Okay, so if you're thinking you want your gut telling you to expand it, what does that mean?
They call us like exponent for it. Make
Okay.
it a bit crude.
We make it look pretty.
5/3.
Why make it 5/3?
3/3, 3/5.
3/5. Power over root. Okay, so now what? What cancels out? And I'm left with 3/5. No calculator required, right? 15. Log base 5 of negative 25. Everyone, please have their books open to page 188 for a moment. Page 188. You're on page 188. The directions say for x greater than 0 and a greater than 0 and a not equal to 1, y is equal to log base a of x. Y is equal to log base a of x. What does this say about a? A has to be what? Greater than 0 and not 1. Okay, well a is 5. Is that okay? And then it says x has to be greater than 0. Well, is x greater than 0? What is x? Is that legit? X is less than 0, which means you can't do it in a solution. That's your domain. Do we understand that? I'm going to tell you right now, for 14 I would condense it. And I think outside the box there. Number 18.
14.
Think about it. We're going to go on to 18 first. 18. Sorry. Divide by 4. Log base 10 of x minus 6 is equal to 11 over 4. Now what? And you might make it an exponential function, correct? And the reason why I have to do that is because I need this 10, those all become exponents. That's canceled out. I have x minus 6 is equal to 10 to the 11 fourths. Okay? This is what I showed you yesterday, which one side to the other. Now, what Alec is doing in his head is he's sitting here saying, well, this is just easier, right? It's exponential function. The base is 10, 10 to the power of 11 is equal to x minus 4, x minus 6. It is. But what we taught you yesterday, what we learned, was how to get rid of exponential functions and logarithms or inverses of each other, so that's how you get rid of them. Okay? The 10 is the base.
Why do you bring the log 10 to all that up?
Because that's how they cancel out. If your brain would rather write this as an exponential function from the get-go, it's the same concept.
Because you could just do like
Exactly the same concept.
whatever you do on one side, like you just had 950 each side, it would still be equal.
Exactly. Okay? So now, how do I get rid of that 6? Not to 10. You will, but this is a number, and it's a big number. So what you have to do is go over to your calculator. And that was 10 caret 11 divided by 4 plus 6. And do you see it gets to 568.341? Okay? 26. Sorry. I could skip the slide. Why divide by 20? This is outside, it's just kind of like hanging out there. So I'm going to have 100 minus e to the x over 2 is equal to, cross out the zeros, 50 divided by 2 gives you 25. Now what? Subtract 100. Negative e to the x over 2 is equal to negative 75. Negatives cancel out, and I'm left with e is equal to e to the x over 2 is equal to 75. How do I get that x out of the exponent position? The opposite of an exponential. The logarithm. I have a base of e here, so what do I have to do on both sides? I need to take the natural log of both sides. So the natural log of e to the x over 2 is equal to the natural log of 75. Those cancel out, and I'm left with x over 2 is equal to the natural log of 75. Keeping in mind the natural log of 75 is just a what? Number, right? Now how do I solve for x? Multiply by 2, so x is equal to 2 times the natural log of 75. And somebody please type that in their calculator and give me the decimal.
8.6.
Thank you. $26. You notice subtraction, there's two logarithms in there, isn't there? So since they're attached by subtraction, they're actually in log world going to be division. So I have the natural log of 4x plus 1 divided by 3 is equal to 5. So now what do I do? Go with what Alec had done earlier. Go with his gut. Sorry. Nope.
Get rid of the natural log.
Get rid of the natural log. How do you do that? Write it as an exponential. So how do I write this as exponential? What is the base? E. So this is going to be e to the fifth is equal to 4x plus 1 over 3. I wrote it as an exponential. What's the base? E. Cross the equal sign. That's your exponent, and it's going to equal the big number. Okay, we don't like this stuff, so I'll show you 100% the long way. E to the natural log of 4x plus 1 over 3 is equal to e to the fifth. Those cancel out. That's what was bugging you? Now, what can you do? Well, I'm going to leave this e to the fifth as a number, because it just is. So I'm just going to leave it as a letter there, and I'm going to multiply, cross multiply. What am I solving for? Solving for x. What do I do? Subtract the 1, and then divide by 4. There's x. It's just a number, right? So can you plug that into your calculator and get a number out? Sure you can. So that was going to be 3e to the fifth. Was it minus 1 or plus 1?
Minus
Divided by
4.
4. 111.06. Do we understand that? 27. Sorry. To attach by subtraction, so what do I do? Divide, so this is log base 6 of x plus 1 over x is equal to log base 6 of 29. What do you notice? Bases are the same, so the log 6's cancel out, and I have x plus 1 over x is equal to 29. Now what? No, they do not. I have a fraction equaling a fraction, so what can you do? Cross multiply, so x plus 1 is equal to 29x. Subtract the x. 1 is equal to 28x. Divide by 28. 1 over 28 is equal to x. Cross off 34. Sydney, cross off 34. I was pretty mean on that one again. Okay. 30. What does 81, 243, and 3 have in common? I'll divide by 3, but more importantly, I can express 3 as a 2a. power. What is 81? 9 times 9, which is 3 times 3, 3 times 3, which is 3 to the 4th. Times 3x plus 2. All over, what's 243? 3 to the 5th. Do these have the same bases? Since they have the same bases and they're attached by division, what do I do with the exponents? Subtract them. 3 to the, distribute that, 12x plus 8 minus a negative 5x is equal to 3 to the 4th. Why is it minus a negative 5x? Because it's a minus in the denominator, and I'm going to subtract them. Because I'm moving it up top. So this is going to give me a positive here. And what can I do with these now? What happens to the 3's? They cancel out, so what can I do? Just set the exponents equal. So 12x plus 8 plus 5x is equal to 4. So this is going to give you 17x plus 8 is equal to 4. Subtract the 8. 17x is equal to negative 4. Divide by 17.
How did you, like, what do you do after you have a fraction? How do you make it just one set of lines?
I distributed this. You see that? That's how I got this. Now, since these two are attached by division, and with exponents, because they're attached by division, you subtract the exponents. So minus and negative became the positive. Okay? Now, number 29 is going to be done very similar to 30. We're not going to do. Would you like me to do any of the other problems, 31 through 35, excluding 34?
32.
32. Okay, what do I have to do here? E to the natural log of the square root of x plus 2 is equal to e to the first. That's gone. I have the square root of x plus 2 is equal to e to the first. Now, how do I get rid of the square root? It is 1/2, so how do I get rid of it? It is a power of 1/2, so how do I get rid of a power of 1/2? Square it. So I'm going to square both sides. So that's going to have x plus 2 is equal to e squared. Now what? Subtract 2. X is equal to e squared minus 2. And what decimal does that give you? 5.8.
It's 5.3.
5.3. 5.38.
9.
Okay. Now, you guys have a good idea. Now, I'll be honest with you, the test is going to be tomorrow over these two sections. This is the review sheet for it. I literally took the test, have the instructions, and replaced. And I replaced the problems and kept all the instructions. Do you understand that? Now, I've given you an extremely long review sheet, and I gave you some very tough problems on it. Okay? One thing I do want to talk to you about tomorrow, you listening, is you to make sure that it's in your domain. Okay? Whenever you plug and plug X back in, if you were to look at that answer and say, is this answer going to give me a negative outcome for my domain, then it's not a solution. Have a great day, folks.